Frank is a 15-year-old POS. So, because we have wasted enough time with Frank, no daily quiz. If you didn't ask questions on the homework, I assume you know what you're doing or you don't care. Either way, quiz happens Monday. So, instead, we got a packet coming around. Chapter 1. We ran through the basics. That's everything that you better know before you walk into this class. Here we go. That packet's a little double C thick. Because Chapter 1 is going to take us a while. In fact, most of the sections in Chapter 1 take us 2 days. Because we bogged down a lot. Chapters 1, 2, and 4, each of them in the past has been 2 to 3.5 weeks, each chapter. Chapters 1 and 2 is all about analysis of functions. Taking everything that you learned the rest of your mathematical career and making sure that you can analyze the living crap out of it. So you know things about graphs, all the stuff that you should have learned along the way, particularly in Algebra 2, but maybe we didn't have enough time to really hone in on it. We make sure you got it now, okay? Because that's what preps you for the calculus part of your future career. Remember, we have the dubious honor of getting you ready for trig, calc, and stats. Okay, so heavy on the function analysis. If at any point as we're doing stuff here, Frank decides to take a giant dump again, I'm just going to quit. Like, done. I'm just going to call it off. Yours was the only video that even happened yesterday. By lunch, the entire smart board was turning off and on and off and on and off and on and off and on and off and on. By the afternoon, it wasn't working at all. By the end of the day, my computer didn't even register it, like it didn't exist in the hardware. And we were going old school, like it was 1999. Hopefully we don't have to do that because I think I might throw something heavy. But here's hoping. Starting with our number sets. Please tell me you remember these. I know I went through them with Algebra half the other day. I know I reviewed them with Algebra 2. Did we talk about the number sets in here? Yeah. Like how you actually get each of them? Okay. In the beginning, there was Alabama math. Well, probably more like Arkansas. Naturals. Did we talk about what each of these are? Yes? No? Maybe? Okay. So, we'll do the turbo version then. You start with naturals. Think fingers and toes. I can't even start at 0. I start with 1, 2, 3, 4, 5. I count with my fingers. Okay? In Arkansas, they can count up to 21. Yeah, man. Sometimes you end up with an extra toe, you know, blessings of your sister cousin. Then we move on to whole numbers. Whole numbers, all we do is add in a 0. That's the only difference. Then the ones that we're most familiar with from our mathematical travels are integers. Integers are positive and negative whole numbers. After that, you have either rationals or irrationals. Random thing for the ladies in the room. Do you know that after you have a couple of kids, whenever you sneeze, you're just going to pee for the rest of your life? Bummer. Just like, it just happens. There you go. Yeah.
Like every single time you sneeze.
Pretty much.
Like a lot or just a little?
I guess that depends on how much you've had to drink.
How hard you sneeze.
So, there's a thing. We have rationals and irrationals. We talked about rational means I can do what with it? What do all of these have in common? Fractions. They can be written as a fraction. If you need to write that next to it, you can write it as a fraction. That's what makes it a rational number. I can write it in this form. It fits into my neat little box. Now, why do they have decimals up there if they said fractions? Okay. Remember, a terminating decimal, that's 125 over its place value, tenths, hundredths, thousandths. And then you reduce it down, 1/8. If you have a repeating decimal, you take the part that's repeating and put it over that many digits of 9. Reduce it down. Okay? We talked about all that?
Yeah.
Right? Maybe? I've done the number thing in at least 2 other classes, so I don't know if I did it in here.
We did it like the first day.
Okay.
Yeah.
So like if I had 0.18181818, take the part that's repeating over that many digits of 9. Okay? If you have a different one that's like 0.08333333, then you break it up into chunks. You take the terminating part plus the repeating part. And then, yeah. So that was all middle school, just making sure you remember what the different sets are. Irrational numbers cannot be written as a fraction. So radicals, not just square root, the 5th root of 2. Irrational number. It's a decimal that goes forever with no pattern to it. Also, our special numbers, what are they? Pi and e. Okay? So, the reason we got to know those is because we start with set builder notation. In set builder notation, the very end part of it is tell me what set you're talking about. Okay, there are going to be 3 parts to it. It's always all x's such that, that's what that line means, such that. In fact, we should probably write, this is all x's such that. That's what this is. Then it gives me the rule that you're following. Then it gives me the set it belongs to. And you want to be as specific as possible. So if I'm only counting 5, 6, 7, 8, 9, 10, 11, 12, ... What's the most specific that can be? I don't want to say rationals. What's the most specific that is? Naturals, right? Because I didn't even have 0 in there. I started at something above 0. We call those cheerleader numbers. Okay. So, yeah, that's a builder notation. Let's make sure that we can actually do it. Mother. Y'all notice that the whole board is shifted over about 3 inches? No, because I finally got it working. I'm just going to roll with it, and I got prep next hour, and then me and Frank are going to have a conversation. And by conversation, I'm talking like Edward Norton have a conversation with him out in the parking lot. That's a Fight Club reference, if anyone hasn't seen Fight Club. He's crazy. Tyler Durden is actually his imaginary friend. It's him. And then he just beats himself to pieces. So, oh, hey, fun fact. My marker thing's gone. Hey, at least I can write, whatever. So, I'm going to start with, this is all x's such that. Now, give me a rule. Usually, it's an inequality. What's a rule that can define this set of numbers? Okay. X is greater than or equal to 8. And then I have to be very specific, because if I just look at this rule and I don't say anything else, I have to assume the real numbers. Well, 8.6 is greater than or equal to 8. That's not on this list. So now I put the set that it belongs to specify natural numbers. So I'll say all x's are an element of, remember that from day one, the natural numbers. And then close your brackets. If your set brackets are bad, you know what? As long as I know it's not a 3 or an E, whatever. Don't have to be pretty. If they ever give you an inequality, well, they just gave you the rule. This is all x's such that x is less than 7. You see how... What? Oh, because the blank box was above where it was supposed to be. I left the explanation there instead of the problem. I always take this snapshot right out of your book, and then I put a white blank box over the part that's worked out so we can do it together. I put the box on the wrong thing. The wrong emphasis on the wrong slobble. Okay? So, anyway, this is what it was. The explanation right below it that's on your notes says... Up here, this is a specific set of numbers. It is stated that I will follow this number pattern, so I know it's the naturals. This doesn't have anything like that. It just says x is less than 7. Well, negative pi is less than 7. So if they ever give you just an inequality, you have to assume the real numbers, so you cover all the possibilities. You see the distinction between the first one and the second one? Okay, multiples of 3. If they ever give you a specific condition like this, where it's one thing based on another, you're actually going to set up your set builder notation almost like a formula. You're going to say all x's such that, what's an example of multiples of 3? What are multiples of 3? What about negative 300? Okay, the word is right in there, right? Multiply. I should be able to take something times what to make these numbers? 3. So I'm going to say all x's such that x is 3 times a number. Right? 3 times a negative 81 is negative 243. That's a multiple of 3. But if I take 3 times 5/3, I get 5. That's not a multiple of 3. So what do I restrict n to instead of x to make sure these always end up multiples of 3? Integers. So instead of saying such that x is an element of, I'm going to say n is an element of the integers. And it's always going to be like that. Whenever you see the problems that are multiples of bleh, they're always going to be written all x's such that x is bleh, times n, where n is an integer. That's just how you do multiples. Because a multiple is defined as an integer times this thing. I don't want it to be a fraction. I don't want to say 1/2 times 3, because 3/2 isn't a multiple of 3. Okay? So, I do some, you do some. There's some set builder stuff. Come on down here to the guided practice. Don't worry about the thumb stuff at the bottom yet. Write them in set builder notation. Suppose I didn't even do attendance because I was fighting with Frank. I see one of those, one of those, one of those. I don't see one of those. Power of Christ compels you. I see one of those, 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 not one of those. One of those, one of those. One of those, 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 one of those. Cool. Huh. First one, rule. Nice and easy. Okay. And because we're counting on our fingers and toes, counting how many sister cousins you got, we're going to say x is an element of the naturals. Okay. Then the rule is already given to us. And because there is no set of numbers to specify, I assume all the reals. All multiples of pi. Now, just because I say multiples of doesn't mean that the things in the set are actually going to be integers. I just have to multiply them by integers. So it is x is pi n, where n is a integer. Okay? So even though all of the numbers in this set are going to be irrational, I define them as an integer times pi. Same thing goes for e. Same thing says if I wanted all the multiples of square root of 7, I would have square root of 7 times n, where n is an integer. 1 square root of 7, 2 square root of 7, 38 square root of 7. They're all still multiples of square root of 7. Okay? So, down at the bottom here, I'm betting most of us are cool with 1 and 3. How do I do 2 and 4? it's still the rule, right? Even though it's a compound inequality, that is still the rule. So if I wanted this compound inequality, I would just all x is such that this, and then what's my set? It gave me inequalities. It's reals again. Remember, it's when we have specific numbers that we can go down to integers or whole numbers or rational or naturals.
Why wouldn't that one be all or integer? Because it doesn't have like symbols, right? Oh, because it doesn't have negatives.
Okay. All reals, because anything less than 0 or anything greater than 8. Well, negative 25 pi is less than 0. And because I don't have these specific numbers here to show me that I'm only in integers or only in naturals, if they give me an inequality, I have to assume real numbers. Yep.
Where would you see set builder notation?
Never.
Perfect.
I told you on day one, pre-calculus is setting the foundation previous to the next 3 classes. Now, also, hate to tell y'all, once you get past maybe DiffyQ and non-Euclidean geometry, everything you do is just proving math. It's either high-end calculus, differential equations, and physics, or proving things. Like, you hit a cap to how much real-world math you're going to do until you learn how to prove the math, so now you can apply the math. Just like you did that, you learned the basics in Algebra 1 and geometry, and then you proved why a bunch of stuff worked. You learned the basics in Algebra 2 and PreCalc, you'll go prove why things work so that you can then use them. You have to know why the thing worked. You got to read the instruction manual before you can turn on the machine. Okay? It doesn't work with math. That's how you end up with what's-her-face scamming people out of billions of dollars and saying, you know, she wants to be a Steve Jobs lookalike. Yeah?
So it says if possible, and that's impossible. Nothing's less than 0 and greater than 8.
What word did you just put in between less than 0, greater than 8? You said and. I gotcha. That's a good thing to ask, though, right? Because if that was an and, there's nothing that is simultaneously less than 0 and greater than 8. Empty set. Now remember, if you ever have to do empty set, don't do this. That's like calling someone Mr. Sir. It's redundant. You put set of the symbol that says empty set. This is effectively saying like it's redundant. It's too much. So just use the empty set symbol. No, that's a good question. If that was an and, I would just put empty set because it doesn't exist. I can't even go up a slide. The button's gone. Only forward. This is like quintessential Chad dad trying to drive an RV that he rented for the weekend. There is no backing up. You go around the block and try it again. Okay? Interval notation. So if I'm going to be with all real numbers, then set builder notation is pretty overkill. If I'm going to be using all real numbers, which most of the stuff that we do in math, we do cover all real numbers. Right? When I have input for x, I'm not only putting in 1 and 2 and 5, and I might put in 3/2. I might put in 2.68321. Okay, I might put in other things. So to cover all real numbers, I'm going to stop using set builder and move over to interval. And this is what some of you saw in Algebra 2. I know I try to at least introduce it to kids. Some teachers exclusively use it. Other teachers, you've never seen it before. But it's pretty simple. You have a parenthesis or bracket on your lower boundary for whatever you're talking about. And then on your upper boundary, okay, so a parenthesis is open circle. You're gonna get real used to MC Hammer in here. Can't touch this. Whereas this says or equal to. Tor? 2. There we go. Pretty simple. The parenthesis says you get as close to this number as possible without touching it. The annoying younger sibling. I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. 4.99999999999999999999999999999 is not 5. I'm not touching you. That's what the parenthesis is. Now you can still get decked if you do it. But that's what a parenthesis is. As close to it as you possibly can. And it's not really possible to show that either, is it? Can you graph for me as close as possible to 5 without touching 5? Like, if you tried to say 4.999999999, isn't there a 4.99999999993 that's in between there? And then you start getting all philosophical about it, saying that within a finite space, there's still an infinite number of things. Isn't there an infinite number of numbers between 0 and 1? Because for every number that you can think of, there's a number between that and 0. Pick the smallest number you possibly can. Start with the decimal over there, write zeros all the way across this board, and then put a 1 right there. Couldn't I just add one more 0 and it's still in between them? So there is an infinite number of numbers in a finite space. Now you're getting into number theory. If that actually tweaks any of your interest, Math Circle with BH, I think Nog runs half of them. He'll run you through stuff that just makes you go, dude. Okay, like really, really cool stuff. I've had kids come in here and start doing proofs of infinity is actually finite, showing me things like that after going to BH's Math Circle. Talked to Spear. I don't think Keeler does it anymore. He used to, but now he's like joined the business side. So ask Spear, and I know that they'll load up kids in a van and just go over there. It's on Saturdays. I think it's once a month. It's worthwhile. But anyway, upper and lower boundaries. If you ever have infinity, I want you to pay attention to all the infinities over there. You notice all of them have parentheses? Why would I not be able to touch infinity? Right? Infinity is an idea, not a location. It's a goal. You probably, okay, and getting all zen on it. Perfection is a goal, not a reality. Perfection is a journey, not a destination. You don't actually get to infinity. You run down that number line for 1 billion years, and you're like, cool, I'm here. And then you see it goes on for another 1 billion years. Infinity is infinite. You can't actually touch that number. So that's why if you want to put next to this, infinity, plus or minus, will always have parentheses. Never put a bracket on infinity because you cannot touch infinity. No. Okay. -1, -10, -1 billion, negative a googolplex, negative infinity's that way. You're never going to get there, right? I mean, if you're Mark Wahlberg, you might. Wasn't there the movie? Which one was it where he went in the black hole? Ended up getting all psychedelic and then. Okay, not Bing Bong. All right. Anyway, we're down the rabbit hole here. Let's come on. Interstellar. There we go. Interstellar. Was it Matthew? Oh yeah, that was Matthew McConaughey. That's right. Who am I thinking? I'm thinking Matt Damon and The Martian. They're movies that involved cool space stuff that came out around the same time. So, if I'm going to use interval notation, this one specifically says, here's your lower and upper boundary. So -8 and 16. But the inequalities on them tell me whether I'm using parentheses or brackets. Can't touch this. And I had a kid get my quote book for that. You can touch this. Like, dude, Cody, stop. Just stop. No one wants to, but. Okay. X is less than 11. I have an upper boundary, right? And because the other one is everything less than, it goes all the way down to negative infinity, which we can't touch.
I wish I had this chart for when I had to do the range because I could never figure out which side it was supposed to go on.
It's supposed to be like a number line. Negative infinity to positive infinity. Lower boundary, upper boundary. Which is going to come in real handy right here because now we have a compound inequality.
Because it doesn't have an equal sign.
Because it's not this.
Oh.
If you touch your sister, I swear to God, you are going to be grounded for a month. I'm not touching you. I'm not touching you. I'm not touching you. Yeah.
So if it's always the greater than or equal to or less than or equal to, it's the bracket. Or is that not?
Yes.
Okay.
If it ever says or equal to, that means press button.
Okay.
You can be here. All right. A compound inequality. Well, if I look at that on number line, again, negative infinity to positive infinity. This says everything that way or everything that way.
So would it be two different things?
Uh-huh. And if you write it out on a number line like that, you can see exactly what it's going to look like. It is can't touch this, can touch this, can't touch this, can't touch this, and yes, ma'am.
Was that supposed to be -16?
Did I? Ah, son of a. Yes. How do I say? Yeah, I'm getting there. How do I say or in math land when I'm dealing with sets? Union, which is why we reviewed it on day 1. This is going to be negative infinity to negative 16 union 5 to infinity. Okay. Where's my cup? Where's my cup? That's what I was saying all summer long. Algebra half is freshman. So, I do some, you do some. Put them in interval notation. Argue with your neighbors, make sure you all got it right.
saying it like that in my head now.
What, they can't touch this? What's really funny is we start doing domain and range and we're using the unions and the parentheses to say can't touch this. There's always a quiz or a test within the next couple of weeks. It's dead quiet in here and I hear one kid over here just working nicely.
That's gonna be amazing.
Someone's gonna do it. Someone always does.
Nah, we're all gonna do it.
No, it's just the power of suggestion. Case in point, do you know that yawns are contagious?
Yes.
Okay, do you know that you don't actually need to see someone yawn? You can just have someone say the word yawn a lot, and now everyone here is fighting the urge to yawn. You don't even need to do it, you just need to say it, and it puts the idea in their head.
I can just hear it and do it.
Yep, because it plants the idea. So we should have -4 to -1 equals this, but does not equal that. Greater than or equal to -3, so all the way to infinity, but can't touch this. And, all right, let's see who fell into the trap. X is greater than 9. Would you agree it's this? Greater than 9. X is less than -2. And it does say or. Why is this wrong? You got to think about the order of the number line. Because right now, your number line says 9 is less than -infinity. So, oh, screw you, Frank. That is not stupid, that is clever. You need to put it in the correct order. Okay? Now, right now you think, well, that's not really a big deal, but as we start doing domain and range with these, your domain should read left to right like the number line of the x-axis. Okay? So please make sure that you put them in the right order. Maybe make a note to yourself to put them in the right order. It should read like a number line. Functions. This is going all the way back to algebra half. If you took algebra 1, you did this. Okay? I'm just saying the first half of algebra. A function. Think of it as the analogy that I always used was a pop machine. You press the button, input, domain, independent variable. The rule is all the mechanics inside the pop machine. It spits out the pop that you want. Okay? Output, range, dependent variable. Depends on which button you pushed. What happens if I press the Mountain Dew button? Ka-thunk. I get a Mountain Dew. If I press the Mountain Dew button again, if that is a functional machine, what should happen? Another Mountain Dew comes out. If I press the Mountain Dew button again, and I get a nasty, like, cherry cream soda, that is not a functional machine. It didn't do what I told it to. Okay? We match input and output, domain and range. Specifically, to be a function, every element of the domain has to only go to one element of the range. Most of you probably, if you don't have your own car, at least drive something every now and then. I turn my windshield wipers on. My windshield wipers clean my windshield. The next time I get into the car, I turn my windshield wipers on and the horn starts going, meh. Is that a functional machine?
No.
Because my input did two different things. Now, if you wire a person's brake lights into their horn as a prank on your buddy, well, then that's just funny.
Did you do that?
I didn't do it. I just assisted. So this, I have set A, set B, domain, range, input, output. Is it a function? Does every button on the machine do only one thing?
No.
I press the 2 button. It does this. I press the 3 button. It does this. Did the 2 button do one thing?
Yeah.
Can I have more than one Mountain Dew button on a pop machine?
Yeah.
Right? As long as that button does the thing that it's supposed to do, it's good. What happens if I flip-flop this, though? Because now I would have 8 doing 2 different things. I press the button, the volume goes up on my TV. I press the button again, and our garage door opens.
Universal remote.
Yeah. Okay, now y'all are y'all are young enough. You probably don't remember the bandwidth days of 2.4 gigahertz. 2.4 gigahertz is what a lot of RF or radio frequency devices were on, like your cordless phone for your landline being on the same frequency as your garage door opener. So when someone called you and your phone rang, it would open your garage door. This happened. Okay, and then you would have to go into the settings and you'd have to change which channel on the bandwidth it was. 8 would go to 2 different things. 7 goes to nothing. That's okay. It's the button that does nothing. Everyone's got that button on their remote. They have no idea what this does. I pressed it and nothing happened. Okay. It would still not be a function though because 7 doesn't map to anything. Every input has to go to an output. So you should know this as a vertical line test because every input is an X. Every output is a Y. So if I have a vertical line here, that means I pressed the 2 button and it gave me a 3. Cool. I pressed the 1 button, it gave me a 4. I pressed the 0 button, it gave me a 0. I pressed the -1 button, it gave me a 1. Every time I press the X button, it does one thing. But what happens if I press the 2 button and it does 2 different things? X is mapping to do 2 different things. Okay? Imagine you're playing around on that device that you absolutely can't live without, and you go to press delete, but it does send. Always put it in drafts first, give it 5 minutes, then decide if you want to send it. Because otherwise... Okay. So, each of these I want you to tell me, is it a function or not? Like, we're going to do them together, these ones together. Okay. The input value is your ID number. The output is is that student's score on a physics exam.
Okay, so you put your input in.
Okay. So, say... Okay, I input Aubrey's number into campus. I click on physics. Do I only see a score on a physics exam? Or is it going to give me multiple? Okay. Now, this is where someone can argue. Well, it depends what time of the semester. Right? Right now, on day, what, like 7, 8? That's it. Okay. On day 7 or 8, the odds are if I look up your ID number for a particular class, you probably only got the one score, right? I got them right there. Okay. If I do that in another 3 months and I put in your ID number, am I going to get... This is where you end up arguing about the English of the math problem. It says, is that student's score on a physics exam? What if it said on a particular physics exam? Are you going to have more than one score for that test? Okay. Then you start arguing. Were you able to retake or not? Okay. So if you're willing to argue that, you got to be willing to write. Okay. I'll tell you right now, teachers, we absolutely love it when you explain your thinking. I got so many points in high school on stuff that I did not get right because right next to it, I wrote why I thought that. If I said next to this, the input is your ID number, the output is student score on a physics exam, I would say not a function because more than one exam taken. Don't just say no, right? Tell me why. Maybe I said no or yes if a specific exam. Okay? If you are willing to quantify your answer, I'll give you credit if it makes sense, if it's logical. I've had kids find loopholes in my wording. You didn't say this, so it could be this or this answer. I'm like, well, you got me, right? Okay, quantify your answer. Yes?
So that's a quadratic, anything because quadratics can't go sideways. It's like, not supposed to happen.
Wait until chapter 7. Yes, they can. Turns out you only know about half about parabolas, as there's actually about parabolas. Guess who's back? Back again. Okay. Oh yeah, parabolas are coming back. Chapter 7, conic sections. Now, if you say it doesn't pass a vertical line test, okay, that's a reason. If you say 4 maps to 3/2 and -3/2, that's a reason. Okay? If you say 4 maps to 2 values, if you say fails vertical line test, okay, those are reasons. B, yes or no?
No.
Does every input go to one output? This, even though 0 goes here and 6 goes here, can I have 2 Mountain Dew buttons?
Yeah.
They're both doing what they're supposed to, so that's okay. All right. Down at the bottom, D. It's just an equation. How do I determine if an equation is a function or not? Get y by itself, because the y's are the outputs. If you can show that the y output is one expression, one thing, it's a function. But when I add 2x and then square root, I just introduced a square root. What do I have to do? When I introduce the square root, it's plus or minus. Remember, if there's already a radical there, you just work with it. It's considered the principal root. But if you put the radical in place, all even radicals get plus or minus. And because my output is now a positive or negative value, that one is not a function. Okay? Because I have both a positive and negative output for every input. So we got words, we got tables, we got graphs, we got equations. Your turn. Are they functions, yes or no? Yeah, crap, now I'm going to have that song in my head all day. Two trailer park girls go round the outside, round the outside. Yeah.
I could just hear the chicks on the
No.
Is it always a function that passes the vertical line test?
In fact, that would be your reasoning. You would say it's a function because it passes vertical line test.
That's what I'm saying.
Vertical line test, probably the easiest one to do, right? Does it ever hit it more than once? Now, remember, even though this is going to have such a steep curve that at some point it almost looks like a vertical line, if you were to get that graphing calculator and you zoomed way in, so like your X window is only 1/100th of a unit, you're going to see that tiny bit of a curve to it. So if it's curving here, you have to assume that it's continuing to curve. Okay? Our functions, our relations will not just curl back on themselves. That doesn't really happen yet. B, yay or nay? Why not? And you would say that. You say 5 maps to both 8 and 9. Or 5 has 2 outputs. Okay, D. Yeah, it's a linear equation. It's a line. Lines are functions. Okay. The input is the area code. The output is a phone number in that area code. I heard someone say the magic words. Bruh, South Dakota. 605. Everyone. Right? Where'd you move from?
Minneapolis.
Okay, that's why.
Other states have more than one. Yeah, that's like there's.
There'll be like 9 area codes within a city. You got to remember, the entire population of South Dakota fits in Manhattan.
There's more people in Manhattan.
That's what I'm saying. The entire population of South Dakota fits in the island of Manhattan.
Yeah, maybe like Central Park. Maybe Central Park.
Yep. So, no. So, we all good with this? We cool? I remember functions from Algebra 1. Okay. Next up, function notation. We've been there. Function notation says, okay, I want to be very particular about this because somewhere along the way, I guarantee you've had a teacher who said f of x is just a fancy y. It was probably a teacher who was just fed up with freshmen not understanding what a f of x was. Okay? F is the name of the function. This position is the domain or input of the function. You will put that x into the rule. This is the expression that defines what you're doing in the function. When you put the input into the function, into the rule, once y'all remember the function machine? The input is x, it does the thing to it, you get y. You throw in the chicken, you get chicken nuggets. Okay? The domain is the input. The function rule is all the gears inside the function. I'm going to do this to the input. I'm going to take the input and divide it by 1,000 pieces. Chicken nuggets. The output is 1,000th of a nugget. Or 1,000th of a chicken. Something. Okay? So, f of x, this is the name of it. The chicken grinder. X is the chicken. The rule, I'm going to chop a bunch of chickens up. The y is the output. That's the nuggets that come out.
Does that mean the nuggets have bones in them?
Maybe.
Are they bone-in nuggets? I want boneless nuggets, dude.
Dude, I found a bone in a nugget before.
Yeah.
Awful. Just hurt my teeth so bad.
Conversation. Gutter. Okay.
Why would you waste time eating around a bone? That makes no sense.
But how did you get the bone?
There's no it's a waste of time.
The great argument between wings versus nuggets. All right, folks.
I'll have my slice of chicken nuggets.
Lock it back in. That was my fault. Get back up here. Do y'all remember the transitive property?
Yeah.
A equals B. B equals C. Cut out the middleman. A equals C. That's why you've had a teacher tell you it's just a fancy Y. That's not true. Okay? This is the name of the function. This is in function notation. If I perform the function, I will get a Y. The name of the function is not the same as the range of the function. Okay? Now that's why we are able to replace an f of x with a y, because they are referring to the same feature, but they are not technically the same thing. Okay? Someone might argue this is semantics, but it is like saying, is this a finger? Or is it a thumb? But it's also a finger. Okay? Phalanges, right? That's just fun to say, phalanges. Okay? So, but they're both talking about the same feature, aren't they? Okay? Where a square is a rectangle, but not all rectangles are squares. A y comes out of the function, but it isn't the function. Okay? Like the purpose of the function is to get me y's. But I can't say y is f of x. They're not the same thing, but they talk about the same feature. It might sound like semantics, but y'all, it matters, especially as we get into proofs. The equation versus the function, y'all know, that's y equals 2x versus the function of x is to double x. Okay? The function of my input is to be doubled. When I do, I will get an output. That's why so many people just say it's a fancy y. That's not true. Okay? They're talking about the same feature. Yes, when you're just writing through things, you can replace f of x with y and y with f of x. But you got to know the difference. Independent versus dependent variable. We talked about this with probability, I think. What's independent versus dependent without using the word depend? Okay. The way that I remember it, independent is the thing that goes in to the function. It is the domain. What's allowed into the function machine? If it's the chicken nugget machine, I probably shouldn't Sparta kick Colby in there. Okay? Colby is not a part of the domain. All right? The dependent variable the dependent variable is what comes out of the machine. Go to the Tyson plant and say, what are y'all making today? Depends what we put in the chicken nugget machine. Okay, this is the output or the range. They are typically x and y, but not always. So, function values. No, stop that. All right. So when I say g of 6, g is the name of the function. This quadratic is the rule of the function, the guts of the machine. This is what it's going to do to my input. So if I say g of 6, that means I want you to square 6, add it to 8 times 6, and then subtract 24. That's what the machine will do to that particular chicken. Or Colby. Or Colby, yeah. Y'all, parentheses are a thing. Please use them. I think somewhere along the way you have made a mistake involving usually exponents or negatives because you didn't use parentheses. So please, please, please put that 6 in all spots and then say that's 36 plus 48 minus 24 is 60. Okay. If I say g of negative 4x, again, I'm missing my little g of is things squared plus 8 things minus 24. In there is going to go a negative 4x. Press the negative 4x button, what comes out? You see why you would want parentheses there? Because so many kids are going to say negative 4x squared. I've had kids just write negative 4x squared. No, you square the whole thing. Oh, okay, negative 16x squared. No, negative 4 squared is a positive. Okay. Minus 32x minus 24. Someone usually asks the question, well, hey, can I do this now? You can, but it's not simplified. If you still have parentheses, it implies there is another operation to perform. If there's something to still do, then it's not simplified. So don't factor something out just because you have been trained to factor. Like, C thing must factor. How many of you always put your variable on the left? No matter what. Variables just go on the left. Or do you do 5 equals x?
Oh no.
Oh no.
No!
I do that all the time. I just feel like I have to
Just go
like I
forever
do that all the
doing same
time,
thing.
and then I end up writing it the other way because I feel like it makes teachers mad if you don't.
The only time that I say you need your variable on the left is if we're doing inequalities, because that's how we read them. If I say 5 is greater than x, doesn't your eyes kind of roll up to the top right corner of your head, and then you say, well, 5 is bigger than x, then that means x has to be smaller. Okay, x is less than 5, right? Oh wait, no, that's a left side, right? Left is analytical, right is creative.
Right is creative, left is analytical.
Okay, yeah. But now, g of an entire expression. G of a thing is a thing squared plus 8 times a thing minus 24. If I plug in an entire 5c plus 4, first of all, don't square like a freshman.
No freshman.
The first kid I see do this and move on, you, me, skate park after school. You squared like a freshman. What's missing? That middle term. You have to, if you got to write it out because it's just been too long, if you have to write it out, write it out. First, outer, inner, last. Okay? Or, if you remember a little trick for squaring binomials, it is always square the first one, square the second one, multiply them and double it. Because you're going to take 5c times 4 and then 4 times 5c. You're going to have 2 of them because you're squaring the binomial. Multiply and double. We did teach you that all the way back in Algebra 1, but usually that was around the part where kids were just like, oh, just do FOIL because it's faster. We tried, there's usually a section where we show you a bunch of mental math tricks, and then you decide to just not do that and use your calculator. This is one of them. And then combine like terms and finish it off. Poor favor, we have 25c squared. I got 40c's. 40c's is 80c's. 16, 32, 48 minus 24 is 24. Okay. Your turn. Be not afraid of the rational expression. No.
Be not afraid of the algebra fraction.
Get him. That don't work on me. I hate coffee. I hate tea. There's a reason I'm this big. I stress ate my way into a new wardrobe, and then I poured Mountain Dew all over it. Enjoy that while you have that teenage metabolism.
Oh, it's not going away.
It's halfway between a trash compactor and a black hole right now, but oh boy howdy. Just wait. I remember going back for the 4th and 5th helping of spaghetti. Never gained a pound. That metabolism goes away. Watch yourself.
I want to be a wrestler.
I'm staying.
Taylor and I were great. No freshman time for us.
Oh no, I was coming fresh off my second surgery, replacing all the screws in my ankle. So my freshman was a 40.
I'm super short. Well, I'm assuming I'm not the rest of college. So
There you go.
I'm just used.
Let's see, 12, 144 minus 24 is 120, 121, 24, 27. All right, we're going to see if we can do this.
121. I want it's not perfect.
3a negatives. A square negative 24, negative 48. A negative 48 A's plus 6 A's is negative 42 A's is 64. 64 minus 16 is 48. 48 plus 1 is... put a question mark on that last one. The question mark negates brownie points.
Okay.
I didn't write it out. I didn't show my work. I'm a screw up. Yeah. Oh, come on. Write it out longhand. Put your parentheses up there.
Sorry, I had to get back at you for not talking.
My wife and I did that for like 12 straight years after watching Shrek 2.
Did you meet her in college or something?
Hmm?
Did you meet her in college?
Yep, freshman year. Thanksgiving.
Oh, fun.
Yep.
For the last one? Is it 4J?
Plus 1 is 49.
Oh, wait, no, it's plus 6. He simplified.
Minus 1, 2,
I got a question mark on there for a reason. I'm not confident.
No, you're right. You're right.
Same thing? Okay. Are we getting there? I'm betting the first two are okay. Some of us might be sketchy on the third one. Use your parentheses. If you have to write out squaring the binomial, write it out. There's one down there. It's got R2 on it. Yay or nay? Do I need to go through the thing or not? Because if you're looking at what I got up here and say, what? Then I should probably go through it. Or, okay, do we get it? We just don't like it.
Yeah.
Okay. All right. Then, domains. Ooh, yeah, we got to stop there. because this needs a little more in-depth explanation given how little we did domain in previous classes. So we're going to stop there, which, if I remember right, means your homework on plan book should be accurate right now. I'm going to double check it before I take Frank out behind the shed and have some words.
I'll write on it in Sharpie and be like, oh shoot, darn. That happened when I went to leave. One of our substitutes didn't know that it was a Sharpie and like wrote all over the smartboard.
You know you can undo that, right?
Yeah, but we didn't care enough. Yeah, you just use hand sanitizer.
Okay.
No, but on the smartboard. They did it on the smartboard, not the whiteboard. Yeah.
I used to do that whenever you left, like the whiteboard marker on the floor, like it erased.
Yeah, but like I know you can do that on whiteboard. You can do it on a smartboard.
No, because it's textbook.
Yeah, that's what they did.
The screen of it is
They did it on a smartboard, not the whiteboard.
Ruh-roh.
Everyone was